All right, we're going to go ahead and get started. So this is your big data stack is too big. And I've kind of realized at this point that maybe a lot of people were thinking I was going to kind of beat up on Hadoop in this talk. That's not what this is. I actually like Hadoop. It bought me my first and second vacation homes. So I'm kidding. I don't have a vacation home. But I think you get the point that Hadoop is fueling a lot of consulting dollars right now and a lot of sales because of the complexity. So I want to talk about sort of how we're seeing things evolve out there. So first, kind of little order of business. I have 2 Solr and actions. The book's getting a little dated, but there's still a lot of really good, meaty stuff in there. If you want to get involved in this awesome getaway, you should tweet. You got to use that hashtag, the 2 hashtags there, because then I'm going to pull them up on my box. Speaking of which, let me jump over and start some sort of crawler, I think, on my box. So those come in. Tweet stream, that looks good. Okay, so now back to the presentation. Let me just take a quick trip down memory lane. Before I joined Lucidworks, I worked for a company based in Austin and had the sort of experience of building a big data solution. Kind of what the data was isn't all that important for this talk. But we really put all the farm animals in Hadoop to work, right? We had Cassandra, Pig, Hive, HCatalog. We did stuff directly with HDFS, Mahout, Scoop, Uzi, and it doesn't matter if you don't know these, but there's a lot of sort of moving parts to this architecture. And I remember one day sort of taking a step back and saying, wow, there are some really smart people working really hard, right, for pretty modest results, what I kind of consider pretty modest results. And at about the same time is when I started introducing Solr into the organization, into the architecture. And first, it kind of started out as a, well, let's let people drill in and kind of see the data behind the metrics. But very quickly, as like the PMs and the business analysts started to use more and more Solr, they're like, whoa, it's fast, and there's all this query power, right? And so that was kind of at the same time. We had all this complexity with the Hadoop stack, and then there was Solr Cloud kind of maturing and taking on more and more in our app. And that really stuck with me. So this talk has kind of been in my head for the last 3 years, and I'm finally glad to be able to give it because I think there's some really exciting things going on in the Solr world, as you've seen in this conference, as well as Spark, and also kind of how we're bringing that together with Lucidworks Fusion. So, just come right out with it. I basically think, and the sort of the main theme of this talk is that Fusion provides, in my mind, this viable alternative that really emphasizes fast access, agility, and automation, right? And you hear a lot about in the big data world about the 4 Vs, or I don't know how many Vs we're up to at this point, but these things I'm seeing more and more with our customers are actually more important. So, bottom line is I actually get to work with a lot of our customers, and kind of some patterns emerge. First one that we see really at Lucidworks, and hopefully a lot of you can identify this, is you get the search engine running, you have some apps, and then people immediately say, it's all working great, but we want better relevancy, right? And there's been talks about rules and all those things, and all those value, but the kind of where people are coming to us is we want better relevancy, but more automatically, more automated. And that's where you'll see stuff like signals, and I'll talk about that in a little bit. But this is one of the patterns that we see. Another one that I think is very interesting and pertinent to this talk is that actually mission-critical data, more of that is actually moving in and finding itself in Solr, right? And behind, and obviously Fusion sits in front of it. And so that's just a trend we see, that people are moving these mission-critical apps. It's no longer just like IT's throwing a bunch of logs in there and they'll get to it when there's an error. This is more mission-critical data, serving like boosted results and recommendations and all those things. I hope you got to see Jake's talk talking about sort of building recommendations And another one that I see that is also pretty relevant for this and really kind of makes sense in the big data world is a lot of big data is unstructured. And so, yes, it's cool to craft a SQL, and I'm going to show you guys some SQL queries and things like that later. But it starts with just doing some exploration on unstructured data. And as we all know, being at this conference, you just can't beat search for that. And another one, and this is going back to my days at Dotchess, and we're building this, this big data stack. I wrote lots of pig scripts. And it was always, get down, do your sprint planning. It's like, yeah, I could probably do 2 or 3 this sprint. And, people had to wait a long time. And then Solr came about, and people could do crazy faceted search and all that. And people get addicted to speed, right? There's this bottom line, like, speed is addictive. And by speed, I'm not talking about other things. I'm talking about speed in getting query results, okay? And then something that I think is really, why I wanted to give this talk at this point and not 2 years ago or whatever is like, it's a pretty non-trivial problem to kind of integrate some of these things, but the nice thing is we've done a lot of that work. And lastly, this probably shouldn't even be on this slide, but the Fusion Spark Bootcamp is something that my team, we almost use it as smoke tests and kind of examples and for when we give talks and things, but it's kind of a set of labs, simple exercises for you to just actually start doing big data things with Fusion, and I'll point to that here and there throughout this talk. Okay, so, but before I get all into the cool queries and SQLs and recommenders and things, we have to talk about sort of an annoying problem, right? And that's data ingest, okay? And I actually think, and most of you that have dealt with connectors and things, like building a good connector is a Herculean task, right? And some of you are saying, well, that's not Hercules, though. That's Sisyphus. All right, and the point there is that, yes, it's a Herculean task, but if you actually tried to do yourself, you probably feel more like this guy than Hercules. It's just a messy business. And the cool thing is that in Fusion, we have a small army of really good engineers, like who live, breathe, and eat connectors, okay? And so all these different data systems that I mentioned on the first thing, a lot of that was so much complexity of just dealing with getting data into the system, right? And so one of the things we do in Fusion is we have these connectors, and then as they feed data into Fusion, they can hit what we call pipelines. And that's basically where you do your kind of last mile of ETL work to get the data into the system, right? And so what we do in Fusion is kind of really make that process of getting data in much simpler. And there's a couple other tools out there as well that I want to mention. But first, I know some of our field team are in here. I put JavaScript when you must, because a lot of the times it's like you just need to make one little last change. And this is where kind of Fusion is very handy in the last minute. Is like you can just write a little bit of JavaScript. And recently we've kind of overhauled some of the performance and things like that in our pipelines to allow you to just kind of put in some last minute JavaScript just to kind of finish off one last piece of your ETL pipeline. A couple other things, though, that I think are interesting around like big data and things is that we use Spark in Fusion quite heavily. And Spark SQL is this, I guess it's an API in Spark that SQL is a bit of a misnomer, but they actually have, very similar to JDBC, they have a data source provider API that you can plug in, and if you go out to the Spark site, there's maybe 40 systems, and Solr actually happens to be one of those, and I've blogged on that a couple times. But a gentleman on my team did a little quick exercise because, DIH, well, it's been out there for a while, but if you want to do kind of pretty big scale stuff with DIH, it can be a headache because it doesn't do sort of the things that like a scoop would do. And so we ran this little test, pretty modest Spark cluster, and we're able to kind of read in 31,000 docs per second out of like maybe 190 million rows or something out of a Postgres database. But he documented the steps there, and I think it's actually pretty cool because it shows like there's a lot of different ways of getting your data moved around and pushed into things. This is just another tool that we provide, again, built around Spark. And then another one we see with our customers as well as kind of this move and trend towards using streaming. And so we have tools that are basically you can stream directly to Solr. And I didn't mention it, but you can also actually stream from a Spark streaming job into Fusion and hit pipelines just in case you have to invoke some JavaScript. But typically you probably wouldn't do that as often because when you're writing a streaming job, you're already writing code. So you can typically just send it into Solr. But I've seen people do nearly 1 million rows per second. Now they have some decent Spark hardware, but and Solr hardware obviously, but that's one way to go. So another sort of theme, I guess, and this talk in my mind is a lot about like themes, things that come up when you realize, wait a minute, we're doing big data with Solr, right? You don't really realize you are until you are. And that's called time-based partitioning. Not a new idea in Fusion. It's been around a long time. Actually, in my previous job, I mentioned HCatalog. We use HCatalog to keep track so that you could do sort of filter push downs when you're reading out of HDFS. HCatalog knows where to go and read the correct blocks based on time-based partitions. So not a new idea. We've built it basically into Fusion. And you could do this with Solr, but it takes some doing, is the bottom line. For example, the idea here is that you have time-based data that your typical access pattern is you want to look at sort of more recent data, right, and sort of optimize around those recent queries. And sometimes you want to look further back in time, but most of the time you're kind of looking at recent data, and then time is obviously always marching forward, so new partitions basically need to be created on the fly and handled automatically. Well, if you want to try to do that with Solr, there's a couple of things that happen. First is, imagine you have a Spark cluster and everybody at this time rollover needs that new collection. Well, Solr doesn't really like 20 different threads asking it to create the same collection at the same time, right? That's bad. So now you need something like some sort of distributed global lock. Those aren't fun to write, right? So it starts to take some doing. And so we've built in all this stuff that basically allows you to, the way I did is I actually have a nice little scheduler that runs in the background. And when I'm about to need a new partition, this thing kicks in, issues this global distributed lock using Zookeeper, makes that really easy to do, and then creates the collection and then frees it up. It does that a little bit before it's needed, and so that basically when docs start flowing in, it never actually hits that lock. So it's actually kind of a nice, simple little solution. But the other thing is right, imagine, and this happens in big data all the time, a task fails and has to get retried, right? Well, now you've already rolled over to the next time frame. So a lot of times I see people trying to do this with aliases, and the problem is you'll get late data, right? So you actually have to have a smart document router that says, I know where this doc needs to go into Solr based off of the timestamp in that doc, no matter what time it comes in, because in Hadoop and Spark world, tasks get retried all the time, they fail, you're gonna have late data. So basically we've handled all those type of things in Fusion. And then sort of on the same time when you're querying this is the whole idea, is like if I want to get the last 7 days of data, right, and I'm doing daily time partitions, well, I only want to hit those last 7 time partitions. I don't want to hit the last 6 months for just the bulk of them to say, no, I don't have that data, right? So you have to have kind of some intelligence built in around the query router, and we have this integrated nicely in with our query pipelines. In Fusion. And so it's basically, it can look at the time range in a query and do that intelligent push down into the right, send the query to the right partitions. But one of the things that inevitably comes up in this, with this type of strategy is, well, we do need to do some deeper sort of historical trends analysis over kind of the long period of data, right? Yes, I like querying over the last 7 days, but I also need to look back 60 days to do some crazy analysis that my data scientists want to do. And so the answer I typically come up with, and it's generally well received, is this is where Spark comes in, right? And this is because, again, we in the Solr community sort of, we want to make things fast. And of course, one of the big themes at this conference is just the massive scalability of Solr, right? Well, bottom line is, I think the best way to go about that is to basically archive data out into some cheap storage like HDFS, and then you can join data in Solr, right, with your archived data in HDFS or wherever Hive using Spark. That's something that's totally doable these days. In the boot camp I mentioned, there's an event sim lab. If you're interested in this kind of thing, it's worth checking out. Kind of just shows the ins and outs of that. Okay, so now let's talk a little bit more on the fun side, the interesting stuff. I love this picture because it's like, that really happened. But anyway, that's what I feel like when you end up building these like big data architectures, is it's just you end up having all this stuff. And why is that? And that's because no one system is really good at all these data access patterns. We have primary key lookups, obviously rank retrieval. I don't need to go into that. Facet-driven discovery. One of the ones that always kind of held me back from doing more with Solr at my last job is this need for doing large table scans, right? That's Hive and Hadoop's bread and butter, right? You can go off and read petabytes, whatever that is. You can go off and read that in Hadoop. But try to go and do, especially this was several years ago, and do that against Solr, you couldn't do it, right? You would crash your production servers, and basically now you're having outages and things. That's changed now. I'm going to talk about that. And then obviously, more and more we're seeing graph traversal. So all these different data access needs ended up with Hadoop architectures that looked a lot like that truck, right? And I built one. I actually built it several times. It never got better until now. So first of all, I do want to mention, there have been talks on this, so I don't want to go into details. But a lot of what we rely on Infusion for doing the table scans and doing joins and all these kind of crazy things at the Spark level is this streaming engine, right? I'm extremely excited about this and where it's going to be going in Fusion. If you haven't looked at it, take some time. You have a flight to go home. Kick the tires, look at the ref guide and start digging into this, because this basically opens up so many more uses of Solr. By doing this streaming. And we saw earlier the SQL talk, right? And I'll show some examples of that. But all of basically what we're relying on in the Spark integration and the large table scans and all that, the building recommendation system sort of sits on top of this engine. Okay, so kind of take a step back. In Fusion, and this is where I've sort of mentioned, a lot of people ended up doing big data type things without really knowing their big data. So one of the things I see when I work with customers is they obviously want to improve that relevancy, and they want it to be automatic, as I mentioned. And so what we do in Fusion is we have this idea of signals. And you all guys that basically understand this inherently, is that when people interact with your search engine, there's all this exhaust, right, that comes out the back. User interactions. I searched on this key term, I clicked on this document. That is very useful information for feeding that back into the system and basically improving relevance ranking, boosting, doing recommendations. All those sorts of things kind of are always happening naturally in your search engine. And what happens is you end up having kind of a small product catalog in Solr, right? And then you end up having just a massive amount of user interaction data that you've captured, right? And that is a gold mine for doing the things that like Jake mentioned in his talk, and then just doing simple things like let's boost this document because people seem to always be clicking on it for this key term, right? Easy stuff. So before you know it, you basically have a big data problem when you're just running a search engine, right? And so what we did, and we saw this a couple years ago, and it's been a really long process of actually integrating Spark in so that this will scale as big as you need, okay? And so that's where we kind of got started as well. We didn't want Fusion to be a big data product, but it ended up kind of needing to be one because this type of automatic feedback into the search engine to improve relevancy becomes a big data problem pretty quickly. Okay. Another area that we see sort of evolving is this kind of whole idea of self-service analytics, right? Is, okay, as I mentioned, a whole lot more, and let me just check the time. Cool, about halfway through, so we're doing good. So, as I mentioned, a lot of the mission critical data is ending up more and more in Solr, right? And why is that? Because you basically start out with a simple project, and then you know, your counterpart director over in another department is like, man, that project really went well, right? Like they got it in, they were on time, people are happy, it's fast, right? And this just keeps happening, and so pretty soon, a lot of very important data in organizations are like locked up in Solr, right? And it's sort of a natural extension to say, well, yes, we have to serve queries and do signals and things like that, but there's also this kind of need of digging into the data at a deeper level, right? And doing what is kind of sort of the hope around analytics and big data is that people will actually be able to do self-service analytics. And so we've started, and this sits on top of the work that's going on in Solr, is that basically really centering around SQL in big data, right? But I actually kind of have a unique take on it that I think is pretty cool since we are sitting on Solr. And I don't have to mention really that, right, there is a big shortage of data scientists, data engineer types in businesses, but I'm pretty sure we can all agree that there's abundance of SQL savvy business analysts, and even if they're not that SQL savvy, it's really not that hard to train them, right? And then a lot of organizations already have invested in the Tableaus and the sort of BI tools and those sorts of things, and so there's just, right, tools that can speak over JDBC, usually SQL, are everywhere, right? They're just, that's not, it's a commodity thing. And another thing that I see actually that's sort of fits into all of this, and it reminds me of this haiku that Aid. Does anybody know Aid? I mean, other than like the committers that have been around forever. So he ran the search at the Guilt group, and he wrote this little haiku, which I thought was cool a few years ago. Anyway, denormalization in big data is like getting to be a bigger and bigger problem, right? And it's great. Yes, you have to do some denormalization to serve your top end, basically ranked retrieval problems, right? We all get that. We've been doing Solr long enough. But when you're talking bigger and bigger data sets, that becomes a harder and harder problem to keep denormalizing, right? Especially, the other problem with denormalization is you have to sort of understand the queries that people are going to ask of the data to be able to kind of put all those fields in there so that you can query it, right? Whereas with a relational database, you don't have to know all the queries up front. You can actually just rely on SQL to figure it out, right? And so that's sort of a thing that I'm seeing that's really would hold all this stuff back is, you know, from being a good self-service analytics solution are some of these problems. So I'm going to actually do a quick little demo on using Zeppelin. Let me see where I'm at in the slides. Yeah, okay, let me do this slide and then we'll go look at the demo. So one of the things that we've been working with that are kind of cool is actually doing a really nice deep integration between Spark SQL and Solr SQL. And why would you want to do that, right? A couple things we see. First off, Spark SQL is way ahead of Solr SQL, which is not a bad thing. It's no dig on Solr. Kevin and folks are working really hard, but basically Spark has like full SQL 2003 support and an amazing query optimizer. I put this link down here. I actually sat in this talk, and Reynolds Zinn at Spark did this. He joined 1 billion rows a second on his laptop right in front of us, okay? That is moving. And that's with Spark 2.0. So that's Spark, and Spark SQL is actually really good, and it's built on Hive, so you can do crazy SQL in there. I can't write crazy SQL. I'm a search engine guy, so my SQL looks very basic. But on the other hand, and I'll show this, Spark just cannot compete with Solr when you can push the aggregation computation down into the engine, right? That's just obvious that, you know, if you have to pull 1 million rows out of Spark and then aggregate them, or you just ask Solr, aggregate the 1 million rows, which one's going to be faster. Orders of magnitude faster to push into Solr, right? And so this is one of the problems that we're actually working on very hard in Fusion is when to do which, right? When can I push down into Solr, and when do I have to just punt and actually do it in Spark? And so that's one of the things we're working on. Again, I have a lab in the boot camp called Movie Lens, works with the Movie Lens database that actually shows a lot of this stuff going on. So let's go very quickly. I like 40-minute talks, but I always feel like they're just 5 minutes too short. All right, so this is Zeppelin. Everybody familiar with Zeppelin? Kind of cool. So it's like a notebook. Has anybody done the tweet yet? Let's see. Okay, so let's look at this first query. And again, this is about as sophisticated as I get. But what's going on here is quite interesting. So I didn't show you this, but I have out in Solr, I have some movie lens. I have all my event sim partitions. Let's do 50 per page. Did that not work? Well, you'll have to take my word for me. Basically, what I have as far as collections in Solr, I'll show you Fusion, is I have a zip code database, and then I have like the movie lens tables, right? And I didn't denormalize them. They're just how you kind of basically get data in movie lens. And so over in Zeppelin, I'm doing this join. Basically what I'm saying is I'm using Solr SQL, but I'm actually pushing down a geo filter. And I'm saying within 50 kilometers, I think is the default of Minneapolis. That's just because movie lens is, I think, done out of U of M. And so most of the ratings in the small data set are in Minnesota. But anyway, so around that area, give me basically the places, and then I'm going to go ahead and join that with the users table, right? And I'll also filter on gender. So this is like ratings of females within 50 kilometers of Minneapolis. Now, that's kind of an ugly inner join, that sub-SQL there, but I think it's important to realize that this guy basically does what I was showing, is it decides, okay, I'm going to push that inner sub-SQL down into Solr, and then I'm going to do the join, because Solr doesn't support joins and all those type of things, in Spark. Right? So we'll pop over to Spark here. As you can see, like, you can dig into kind of Spark and see what it's doing. That should be the last one. But, so it did kind of a broadcast hash join and all this kind of thing. That's a bit of an eye chart, but basically shows the logical plan. So what we've done here, and there's a couple other SQL queries you can play with in Zeppelin. Of course, that's going to do that. Okay. This one is like highly rated movies, 4 to 5, the top ones, but I'm joining on the actual movie table so I can get some metadata. Let's see, what is this one? Okay, so this one is pushing down into Solr. I don't know what's going on with that. This one is basically looking for movies about love and then joining with the ratings table, right? So we're going into Solr, say, what are movies whose plot mention the word love? And then let's go ahead and join that with the ratings table and get like the best rated love movies. I don't know, I was feeling romantic that day, I don't know. But you know what I'm saying? Like, what you can do here is just sort of experiment with Spark and Solr. And this is just, what's cool is this is Zeppelin. And notice the little interpreter I'm using here is Hive. So that basically says it's using the Hive JDBC driver. That's it. So you can point Tableau at this. And of course, you can just write like, you don't have to do these Solr queries, right? You can just effectively write like true SQL. But if you want things to get pushed down into Solr efficiently, you can craft them so they actually do and hit the Solr engine when it makes the most sense. Okay, so that's Zeppelin, and I think it's pretty cool. So what is this one? This is, I don't know, of course, demos, right? All right, nobody's tweeting yet. Either that or my collector isn't working. Anyway, we'll come back to that. Okay, let's go back here. Okay, so another thing we found, though, with all this SQL is And then I'm seeing, I kind of had this idea that all this is cool, and on the side here, and it's not intended to be actually really part of the slide, but that's using the streaming expression to do a join between a couple tables, a couple collections in Solr. We have in Fusion what we call this catalog API, and the idea that I had here was that in a lot of organizations, you typically have like a subject matter expert that knows a particular area of data, but they oftentimes actually have to share that. So the catalog in Fusion actually allows you to register data assets and then just expose them as a view. So for example, if I actually had this, I'm a Solr dude, so I can craft that, right? But then I'm not going to give that to somebody else and say, hey, work with this Solr streaming expression. I can actually use Fusion Catalog to register that in the catalog, and then it just becomes a SQL view, and people can actually just do select star from whatever I end up calling that thing in my catalog. So it's a way for sort of subject matter experts, data engineers and things like that to kind of share their data sets as like simple views, right? And then now, as I showed you with Zeppelin, but it could just as well be Tableau, you can now use JDBC to come in and hit very complex things on the back end that just look like simple views, right? And one of the first thing you're going to wonder there is, whoa, who's accessing which data and what? And so the nice thing that we do actually is tie all this in with the Fusion security. So when you come in through the JDBC driver, and hopefully I can show that, right? So this is like the interpreter, this is behind the scenes. When you come through the JDBC driver, we'll look at the Hive here, if I could find it. JDBC. So this is crazy like Hive JDBC URL, but it's just JDBC. They like to expose passwords. I wouldn't have done it that way, but anyway. Point is, you can come through JDBC, but all of the authentication ends up hitting Fusion. Well, Fusion has an amazing security stack. And again, I mentioned connectors. We also have like a whole army of engineers working on like security issues and Kerberos and integrating with various LDAPs and Active Directory servers. So hard stuff, right? Like enterprise security is a pain in the butt. And so basically Fusion tackles all this. We just tie into it for all the SQL. And then for the authorization is like, you shouldn't be able to come in and query the view I exposed of this, right? This is very sensitive movie data, right? You shouldn't be able to come in and read it unless I give it to you. Again, so Fusion has basically a permissions API that can lock these things down very easily. And the cool thing is behind the scenes, you can use streaming expressions, use all the power you've learned about at this conference, register in the catalog. Now it's just a tabular view, right? It doesn't support graph yet because I can't really grok how to map graph results into tabular, because again, all this is more sort of SQL and tabular results. I'm sure there's special cases, but the graph doesn't quite work yet, so that's one of the outages. But the point here is that now people, business users around the organization can say, I need to join in with like a US zip codes table and do some geospatial stuff on it. They can go through the catalog and save themselves a lot of time and effort. Okay, so one of the things we also did that I think is cool, I'm running out of time, so I'll kind of go through this quickly. Not meant to read that. It's in one of the labs. It's called the Apache Logs Lab, but we're using Spark internally to do a lot of things I mentioned. But at the same time, we're not going to think of every problem you might have. Okay? So one of the nice things is we actually allow you to write your own Scala, submit it to Fusion as a job. We call it a custom scripted job. And then we'll take care of running it in a scheduler, the permissioning, all those kind of things that you need in an enterprise solution. You basically can do whatever you want in Fusion and Scala, but you just submit it to Fusion. So there's a lab for that. Basically had some great talks around machine learning, Jake talks and Grant's talk. They talked a lot about the Search Hub. So this isn't, well, there are a couple labs, but we have some cool things basically in Fusion and sort of the Solr integration with Spark for like doing Lucene text analyzers. I'll basically leave it at that. If you didn't get to see Jake's talks, I'm sure he'll have his slides up soon. And then lastly, to kind of wrap up, one of the other areas that's big in big data is this idea of machine learning. And so in Fusion, what we do now is we basically say, well, use Spark or use whatever kind of tool you love, because data scientists tell you those apps that allow you to kind of go to a form and fill in some fields and train a model, right? It doesn't work that like. Does it work like that? Yeah. It's very iterative. It's hard to build a really good machine learning model, right? So our approach is, and Jake has a lot of good talks about this, is like use the tools you're comfortable with, and you know, Solr happens to be a really awesome place to store like training data and test data and those type of things. We make it easy to get at those, but the work of developing the model, that's hard work, right? And it's, you know, it's for advanced users. Once you get beyond like 20 news groups. But once you have that model, what do you want to do with it, right? You want to use it, say, in this example, I want to put it into an index pipeline while I'm doing ETL to maybe do sentiment analysis, right? So it's a sentiment classifier. So we allow you to basically load that trained model into Fusion and then serve it through an index pipeline or a query intent pipeline to basically do the predictions at runtime. And so that's kind of where we're at with Fusion, but you know, it gets you a long way for like dealing with actual model serving, what we have in Fusion. And this is an example of, I think, configuring the stage. So you see, this is a kind of form that works, but you have to actually have the model, right? But the bottom line is you basically point at the machine learning model you've already trained. In this case, I called it tweet sentiment. And I think that sentiment classifier didn't end up being that good, but it's just for demo. And anyway, as tweets flow through, they will actually get classified with this thing, and it'll add the sentiment D field, right? And so that's basically how you can use a classifier in Fusion during indexing, and the same thing works basically on the query side. So to kind of wrap up, gotta have a cat picture. You could do this yourself. Right? And this is an open source conference, and you know, Fusion itself is open core and all those things, right? So you could do this yourself. I think my point and why I wanted to give this talk at this conference is like, effectively, don't fall into the trap that we did of thinking like, oh, we're integrating all this cool big data technology, that's actually business value. Because remember, we were working hard. I was probably, when I had this idea, that we were probably like on our third all-nighter that week, right? And it's just like, this is too much work, right? It's too complex. And I think with Spark and Solr and Fusion integrating the two, right, it's a lot easier, right? And pretty soon, you know, it's going to get better. But that's kind of the key takeaway is like Fusion gives you a clear buy versus build choice. So, I mean, I hope you saw some taste of that today in the talk. This is our architecture slide. I think it's a little bit outdated. And then so kind of to wrap up, thank you for coming. You can try Fusion. There's a link there. A lot of what I talked about is actually into the open source Spark Solr library, and the boot camp has some cool labs. And then also 40% off code there from Manning. If you use that, you can get any of their Manning books. So did anybody do the tweet exercise? Or did my crawler not work? Did anybody tweet out? Oh, okay. All right. So let's see. I could do it in SQL, but at this point, we'll try it in Rev tweets. There it is. Query. All right. Cool. So let's see. Let's do a. Let's just cheat a little here. What was it? Fusion? No. We'll see what that does with that. Fusion big data. Let's see if that. Big Fusion data. It's been a long day. Sorry. Big Fusion data. Fusion big data. Okay. How many? 6. All right. Awesome. All right. So now how do I do this? Oh, I know how I'm going to do this. I know how to do this. Haas is here? Where's Haas? Yeah, random, and then you give it a seed, right? Come on, you wrote it. I want to get a random order. Random. All right. So roll the die. Yeah, it should only bring back 2, no? Yeah. Num found. Oh, yeah, okay. Yeah, it worked. That was the num found. Okay, so up top is, who is Evan Volgas? All right, awesome. Congrats. And then who's the other one? The guy. But you already have this. Okay, let's do it again. Let's change the seed. Oh, you came back again. It likes it. Oh, what? Maybe too close of a seed. No? Okay. We'll just get rid of it. I thought it would just give me a different random order.
Rows equal 3, Tim.
There we go. Sorry, it's zoomed in. All right, so guy, and of course me. Not the best idea. Yeah. Yeah, no kidding. Let's do that. What's the user? There we go. Thanks. Probably just going to come up with somebody that, all right, there you go. Leander Reimer. Leander Reimer. Yeah, hey, sorry. All right, I'm over time. I know. Hey, I was trying to get the random sorting. Thank you. Leander.